And we're live. Okay. Hello all, hello world. It's been a little bit, but I've wrapped up my finals and I've wrapped up graduation, so I finally have time again. This is day 220 of studying compilers every day until I land a compiler role. Last time we did a little bit of infrastructure cleanup, and that was all very nice. This time we're gonna go back to value numbering. Hopefully we can get started on implementing it. If we can't, then like all good, but we'll see what happens. What's up, Izarith? Congrats on graduating. Thank you. Yeah, I have a little diploma cover here. I don't have the diploma yet, but yeah, we got a slot for it. Yippee. But yeah, I did technically, I guess like half graduating like kind of makes sense. It's like kind of awkward. I graduated with my bachelor's, so I guess in that sense it does count. Okay. Coding time. Git log. Okay. Okay. So, do you have any changes? No. Okay. Okay. Let's start GVN. Got my diploma in the mail with a piece of cardboard. Damn. Yeah, I mean that is just very unfortunate. COVID graduates really had it rough. I really wish I got better. Okay, GVN. Oh man, how do I even want to do this again? There were two approaches. I forgot what they were, but there was that big paper. Let me pull up the paper again. Where did that go? It's not that. Is it this? Yeah, okay, we found it. I think it's this, yeah. This paper. We'll do that. Okay. Zoom call, holy hell. Yeah, Zoom call is very unfortunate. Yeah, I don't know. I understand like why things ended up being the way they were, but like I wish they weren't, you know. Okay. So there's like a hash-based approach, which is like the local technique that's expanded. The second one is where does it live? This like value partitioning thing. I don't really understand this at all, so that might be interesting. It's very culty, really. I guess that makes sense in some capacity. Also, like my throat's like low-key dying, so whoops. Let's look at comparing the techniques. Excessive equivalences. I kind of want to implement both, but I'm also kind of lazy and don't want to implement both. So I'll probably just implement the hash one. Sure, effects reg alloc. We're just gonna like we're gonna scroll through this for a little bit. And then we'll figure out what to implement. Never worse than its predecessor, sure. What's up, Lane? Decide to put on Rust projects on the back burner to focus on improving C++. Yeah, that's kind of like where I ended up landing. Like, Rust is just fun to write, but I do just gotta like C++ is just like so much more present in the job market that it's really hard to justify not working with C++ more. Wait. Okay, so lower is better in this, I think. Yeah. Single is like baseline, I think, right? We'll just like read through what it says. iLock, whatever. Alright, figure 16, 17. These are all hash-based techniques, it looks like. It looks like none of these perform worse. At least it runs faster, so I think that might be something to think about. I'm not sure how much I care about it, but could be interesting. I think we probably want to do hash-based the more I think about it. Partially because I'm lazy, partially because, like, it mentioned that it's, like, maybe I'm just, like, misreading it, but it eliminates more redundancies. But that doesn't necessarily make it, like, better, per se. But at least, like, in terms of the types of benchmarks we're working on, I think it might be more measurable that way. Yeah, this is interesting. Let's look through this. I'm also, like, already familiar with this, but yeah. I should probably figure out what this, like, congruence thing is. Or the partitioning thing. Oh man. Yeah, okay. Da-da-da. Oh man, okay. Oh man. This is rough. Wait. Okay, how do I even go about this? What's up, Gnomes? It has in fact been a second. I now have one of my degrees formally. So, yippee. The other one I'm still working on. Remove any computation that is dominated by definition from the same congruence class. That makes sense. What's up, Pavlo? Hopefully you're doing alright. Congrats, thank you. Yeah, there's still a lot of work to be done though. I've got a thesis to finish up, I've got 2 more classes I need to take, so that's gonna all be in fall, and then hopefully from that point forwards I'm done. We'll see what happens in the future and if I decide to go back for a PhD, but yeah. What's up, Among Us? Nice. Also, what's up, Niraj? What books should I read if I want to get into compilers? The LLVM tutorial is probably fine. I think if you want to work a lot with LLVM, that's not a bad place to start. My Rex pile, I think this is the command. We'll see if the bot works. Okay, yeah. I think those are probably a good, like, practical introduction to language design and then compilers. Congrats on grad, thank you. I will still be around, but we'll see if I end up doing a PhD. I probably won't, but not saying never. What is GVN? Global value numbering. So, if we compute a expression multiple times, we can just like use the first instance of it instead of recomputing it. Are you a master's student? Now I am. Previously I was both a bachelor's and master's student. Now I'm just a master's student. Well, I guess I've technically only been a master's student for a bit, but I like formally walked like yesterday. So in that sense, like before I was like exclusively a master's student in name. Now I am like in every definition only a master's student. Okay, is there any background that I'm missing here? Let me also like check one more reference resource. I think that might be useful for me. Let me check this. We'll look at more things in a second. Isn't this? No, it's not in that. Maybe it's here? No, it's not here, but I need to read through that later, actually. That's very important. Maybe here? Or is it in here? I'm sorry, this is gonna be off screen for a second. What coding languages do you usually work in? I really like I guess like I've primarily been using C++ and Rust, but I've used like a little bit of Python here and there. Progressively less and less Python, just because I don't enjoy writing Python. But like, yeah, C++ is like probably most of my code for the time being. There's a little bit of Rust here and there, but it's primarily C++. Let's see. Is it this one? Yeah, I think I would trust Lane's like explanations. I think Lane is like pretty accurate on a lot of the stuff, at least. I can't say like exactly because I haven't necessarily like read through all the resources, but I think it seems pretty credible to me. Okay, none of this is useful. That's very unfortunate. Okay. Do you use inheritance or std variant? I've been thinking about std variant a lot more. I've mostly just been using inheritance though. So I guess we could look through this a little bit. This lives in, oh man, here, front end, AST. Yeah, so we have function, prototype versus definition, and then like we go down a level to like instruction, and like these all inherit from the instruction class, and then I just slap the visitor pattern on and I just call it a day pretty much. In hindsight, I definitely should use struct because these getters are low-key annoying and I don't care enough about it. These are necessarily just like data structures, so I think it's like probably fine. Why don't you get into blockchain since you like Rust? I'm a lot less interested in blockchain/crypto. I just think compilers are cool. That's the big thing. That's the big reason that I'm doing this, at least. Okay, let's read through this a little bit more, and then we'll try to start implementing the hash-based approach, or at least like scaffold it out, and we'll see what happens. Yeah. This thing seems really slow. Or at least complicated to make quick. I think we'll just do the hash approach. I think it's simple enough, and I like simple. Okay. Alright. So there's like a local technique. We looked at this before. We basically number each like unique expression, and then like if they are provably equal, then we replace them. Yeah, that's kind of just that. That makes sense. We can apply to an extended basic block. So the only predecessor does not... Wait. So, a sequence where a block is the only predecessor of the next block, and the first one does not have a unique predecessor. So just like straight line sequences of basic blocks. I guess that makes sense. Maybe a member of more than one extended basic block. I guess that makes sense. That's like kind of awkward though. Is this necessarily just like the best way? Oh, I see. So we thought this was too difficult, so we decided to use static single assignment, or SSA. SSA is great. We love SSA. Yeah, so that exists. I'm gonna skip the explanation for now, unless there's like someone that does not know what SSA is, or does not know and is interested. But pretty much instead of reassigning variables, we just make a new variable, and then in instances where you have to like resolve which one is the like actual variable, you add like what's called a fee instruction. What unit do you go to? Northwestern. It is in Evanston, which is in Illinois. Okay. Dominator based value numbering. Okay. That makes sense. So covers maximal length regions without such merges. Handle merges. We rely on this. So if a basic block appears on every path from the start to another basic block, then that first one dominates the second one. If they aren't the same, then it strictly dominates. So a node is able to dominate itself, but a node is not able to strictly dominate itself, at least. Even if you land a compiler rule, we'll still continue the series. I'll probably rename it. I'll probably like get more creative with the names, but yeah, we'll see what happens. I will definitely continue streaming. I might not do Jesus Christ, I can't speak. I might not do it daily anymore. I'm probably gonna like shift away from daily as well anyways, just because like internship is coming up in a week, so that's gonna eat up a lot of time. Yeah, hopefully all goes well, and we'll see how much time I have, but like the commute is like an hour each way, so I'm probably not gonna have a lot of time, unfortunately, because I also want to like be a human being at night, and I also want to apply to jobs for obvious reasons. Yeah. Does your college teach any modern programming languages? It's not really like programming language focused, to be honest. I think like the big thing that the curriculum is built around is that like a lot of concepts are like language agnostic. So it doesn't really like enforce one like primary language, but at least like most of the courses use either like Python or like it's mostly Python actually. But like it's all sorts of varieties of languages. I think almost all of them are generally used in industry. With the exception of like Racket, I guess. But even still, that's like very PLE, so yeah. Can't be a normal human being and use C++ at the same time. That's so real. Okay. Dominator tree, okay. Processes each block by initializing the hash table with the information resulting from value number. Jesus Christ, what a sentence. Shorter but nearly daily, I see. I was thinking about like shortening my streams, but I feel like there's not a lot I can really do in one stream then. I could probably keep it to an hour and it'd be like pretty sane though. That might be something I think about, at least with time. Okay, I'm gonna like, I'll read this and then like I'll probably lock in for a second. What got you into compilers? I took a class in my second year. It was our compilers class. It was famous for like being 20 hours of work a week. And then I like low-key got my ass kicked, but it was like kind of cool. So then like I reached out to the professor after and I was like, yo, can I do research? And the professor was like, yeah, sure. Here's a project. Go talk to this PhD. And the PhD candidate is now going to be my advisor pretty much. Yeah, they're all goated, but that's how I got into it at least. Okay, I'm gonna lock in for a second, so I might ignore chat for a bit. Okay. So processes each block by initializing the hash table with the info from value numbering its parent. Okay, so we just like scoped hash table. We could just use like a stack of hash tables, I think. I think that'd be fine. A stack of unordered map. DVNT, that's what this is called. So what are the other ones at least? Oh, that's value partitioning, I see. Okay. Information it provides. Oh yeah, we read that. Is this all still one big section? Yes. Let's run an SSA name with angle brackets. Okay. Sure. That's good notation. I might steal that for my video when I make it. Alright, when a redundant computation is found, the compiler removes the operation and replaces all uses of the defined name with the value number. That makes sense. So we have like a nice utility to do that for us, which is great. Yeah. Appear in any block dominated by the first occurrence. Wait. Sure. Or as a parameter to phi node. Is this is exhaustive, right? Like, is there a case that doesn't let this happen? Place all uses. Sure. So control flow must flow through the block where the first eval occurred. Okay. Oh, I see. Yeah. Yeah. Jeez, this is confusing. Yeah. What's up, Aiden? We're back in GVN hell. What am I reading? Special treatment. They're getting the passenger princess experience. Must have previously assigned value numbers to all of the inputs. Interesting. Yuck. So the procedure is called recursively process reverse post order. Okay. Wait. Post order is children after. So this is children first. Ugh. That's really annoying. Okay. So just like no loops is kind of what I'm getting from this. Maybe I'm wrong about that, but at least that's what I got on first read. Okay. Updates fee inputs. Holy. Okay, I'm just gonna read the code for a second. I think that might be helpful. So we run this on a block. I think, which block does it run it on though? I think this is the... Oh, I see. So for each child, so surely this is just run on the beginning? Yeah, I think the first block is what it runs it on. We could probably just like implement this, just like copy paste pretty much. Okay, so this is just like a stack. So we make like a new hash table for each fee of that form in B. If the fee is redundant, what the okay. What that mean? Like actually what that mean? If P is meaningless or redundant. Okay, that's helpful. I guess I guess it's based off of uses then? Oh, what's up, Max? I guess redundant we know. We just need to like compute that somehow. We need to figure out how to encode these hashes as well. That's the other big challenge here, I think. I think that's the other big interesting part of the challenge. The first part of the challenge is like just how do I implement this? The second part is like, what am I doing? Ooh, thank you, Aiden. Yoink. Ooh, okay. Yeah, we did this pretty much. Okay, yeah. Local numbering we've looked at. Oh wait, we can use J and K. Hooray. Yeah, so we just do it on SSA. We do not care about... Or, oh, actually this makes sense. I guess we could do it like this. Alright, global time. Accuracy for speed. Oh, okay, sure. That's a good diagram. So we just copy the hash table. We could implement it like this and then just like do more with it. Redundant fee. Oh, I see. Okay, that makes sense. Sure. Did not propagate along control flow edges. Yeah, that makes sense. Strictly on the Dominator tree then, I guess. That makes sense. What would happen if we did? I see. Because then we actually have to like do a fee. That makes sense. Wait, ugh, yuck. So we keep those, and then... Jesus, this is ugly. Wow. That's really ugly. Yeah, I can't lie. I always struggled with like the Greek alphabet, so this is like my worst nightmare, but I'm like learning from it. So like it's getting better as I read through things. Okay. Topological order, sure. Ready and pending. Ugh. Okay, yeah. Data flow, that makes sense, sure. Okay, and then we talk about inlining. I want to add like some inlining stuff in the future. There's some like interesting... There's some interesting implications of inlining, but we will see what I choose to do with it. Sorry, it's just a graph surgery. Yeah, we might do like an inlining pass. I think that might be fun. Is there like... Okay, yeah. Heuristics. Yeah, okay. Well, at least the part we care about is this little pile here, pretty much. Yeah. Okay, so if we go back to this paper, we can figure out what meaningless or redundant is, I think. Like, we'll figure that out. It'll be obvious. I don't think meaningless we care about, but at least redundant we care about. We'll have dead code elimination for meaningless. Yeah. So we handle fees like that. So if it isn't redundant, then we add it in some capacity. If it is, then we add to the list and then we erase it. Oh, okay, I see. Okay, yeah, that makes sense. So let's draw this out. Paint.net. Alright. So we have this block here. This has like 2 in edges. We have like or I guess we could do like 1, 2, and then this is like block 3. So we have like I equals like what is a fee? It's that symbol. It's like a fee of like 1, 2, and then we have like j equals fee like 1, 2 as well. So this first instance here, we'll circle. Let's split screen that and shift this over. Oh, where did I go? Oh man. Where? Okay, here we are. Okay. So this first expression, this is the wrong place. 1 more page, 2 more pages. Here we are. So this one, it's not redundant, so we add this to the hash table. So we have we add like fee 1, 2. Oh man, how do I even draw this? We'll just put like I here. And then the second instance we read, is j, this exists already. So what we can do is we can add j to this, and then we can just erase this. I think that's all of that does. So we just check if there's a redundant phi. Okay. So for each assignment of that form, at each binary op, so we overwrite. Oh, I see. We do substitution with the global value number thing. Okay, so this is just a big like find replace is what I'm getting. But it's like algorithmic in the way it does it. Holy, what is this line is very vague. I don't think this tells me a lot. Okay, we'll just like we'll look through this. Is this done with SSA or are we constructing SSA alongside? I think this is just a binding. I think that's what's confusing me. Okay, so we just like substitute the parameters. We take that question mark. So if it can be simplified to... When the fuck did x per prime come into play? That's very confusing. I mean, surely this is just saying like do substitute if... Oh, simplify first. But we're gonna run the simplify pass before, so we're not worried about that. So we can kind of axe that. So let's just annotate this. I think that will save me headache. Let's add some margin. Canvas size, increase in the middle. Let's make this like 900 by 900. There we go. Okay, annotate time. So this is just insert if new, and then insert, or we could simplify this, just insert and then erase if seen, or map maybe. We'll word it like that. Okay. Yeah, so this is just map, or I guess replace operands. We're just gonna de-jargonify it. This we're just gonna erase. Use inst combine. Okay. And then this is the same thing as before. Right. Yeah, that's what we want to do. So this is just map and erase of scene. We can use a different color for this even. Let's use a different color. Yuck. Size 5? Was that the size? No, size 2. There we go. There we go. And then we can do the same thing here pretty much. Okay. Oh. So for each successor, we want to update the fees. Right? Wait, what? Inputs. Okay, I see. So this is... We could probably put this at the top as well, to be honest, right? We could engineer it as like this going in this like top step while we're processing all the fees. Successor, fees, and this is recurse. Yeah, we'll do it that way. I think that's how I'm like reading this at least. Where did it go? Here we are. What is happening here? Where did I go? Okay, so there, we were reading that. It's called recursively. They must be processed in reverse post order. Wait. We have a reverse post order like iterator thing. Yeah, okay, I see. Okay. How do I remember? Post order is children first. Okay, sure. Had to retouch up on my fundamentals for a second. Alright. So looking through this again. Okay, so we can just like make a queue pretty much, or like a work list at least. But that's like kind of awkward, actually. Or wait, how do we want to like figure out scopes for that then? We could make like a new data structure. Actually, that might be funny. It's just a linked list. It's always a damn linked list. Yeah, okay. Meaningless if inputs have the same value number. Redundant if computes the same value. Okay, that makes sense. Okay, so we value number the fee functions and instructions, and we visit each successor block and update fee function inputs. So which parameter corresponds to input from the current block and overwrite the parameter with its value number. Okay, that makes sense. Alright, we can skip the example. I think this makes sufficient sense to me. Okay. You can incorporate it into SSA construction. I don't really care about that though. I want it split up at least. But yeah, we could worry about that some other time. This might be useful for like, JIT compilers. Okay, unified hash table. This is something I am interested in as well. Where did it go though? I went down way too far. Unified table. So we just use one big hash table. I think that's what we want to do. But we walk the dominator tree. Okay. Since blocks B2 and B3 are siblings. Yeah, that row. So like this horizontal section. The entry for A plus B would be removed from the scope hash. table after processing B2 and before processing B3. That makes sense because we don't want it to be like redundant. So there'll be different value numbers. But if we're using a unified table, we can share it like that. And then we can skip that fee. That makes sense. So replacements cannot be performed online. I see. Okay, so we just need to like do a replacement later, but that's like fine. That's like perfectly fine. We can do that. Yeah, okay. Second pass to eliminate redundancies. Using unified hash results in consistent naming, which is good. Okay. Okay, we should do that at least. Acyclic subgraphs. Well, that's inconvenient, but that's fine. Just no loops. Maybe I should do that, like... Maybe I should do, like, the value partitioning implementation then, just for loop-related reasons. That's, like... That's all fun and dandy. Oh, man. Alright, well, I've done, like, so much reading in this one stream. I think this all makes a lot of sense, at least. Let's just, like, take some notes on, like, global value numbering. Or, like, unified table. We can... Let's write this in, like, green at the top. Just for myself. And then we might implement this. We'll read through the other one next time. We'll figure out what we want to do then. So, unified hash table. So we can skip scopes, but we have to do replacement later. Yeah, so we can get rid of this. We can't do this yet. We can't do that. Can get rid of that. Then we do replacement. There we go. Is that everything there? Anything I'm missing there? I think not really. Yeah, okay. Yeah, okay. So that's all fun and all. What is the... Also, just like real quick, what is this avail thing? Okay, that makes sense. I'll have to read through this a little bit more next time, but yeah, this is very interesting. Notion of equivalence. Computations. Hides redundancy. Oh, I didn't even think about this. That's very interesting. So then it just seems like the hash-based approach is strictly worse then. Right. Because we already do the simplification beforehand in some way. So we'll be rerunning the passes over and over. Yeah, this is very interesting. Wow. Okay, well, I'm gonna read through this more next time, but I think this is a good place to call the stream. I think this is a really successful first stream back. I think y'all can expect more streams for the rest of this week. Next week we'll have to play a little bit by ear though, because my internship begins. Thank you all so much for showing up today. like the stream if you haven't, sub to the channel if you're new. And then check out the description. My Discord is there. It's the best place to get pinged when I go live, and stay connected with the rest of the community. There's also a bunch of other stuff down there. You should check it out. Yeah, I'm gonna go like take a shower and then probably just chill for the rest of the night. Take care, y'all. Take it easy. I appreciate y'all, and I will see you all tomorrow.